work at the Tasmanian Institute of Agriculture in Launceston in Tasmania. Soil carbon is a component of soil organic matter, and soil organic matter comes as a bundle. So it's hydrogen, nitrogen, carbon, phosphorus, and a whole bunch of other nutrients. So if you want to build up soil organic carbon, you have to build up soil organic matter. And you can't build up carbon as an element by itself, you have to build up soil organic matter. So if you want to build soil organic matter, you need to add nutrients: nitrogen, phosphorus, sulfur, potassium. Soil organic matter provides biological, physical and chemical benefits. So biological benefits in terms of habitat for the microbes and fungi. It provides chemical benefits in terms of adsorption, so that's when a nutrient sticks to the surface, not absorbed but adsorbed. And it provides physical benefits, so it provides structure for plant roots and it provides pores for soil moisture or soil water holding capacity. So it's physical, biological and chemical benefits. All farms are starting from a different base. So a farm is a continuum. It depends on what happens over the last 100 years and particularly the last 10 years. So that's in terms of soil carbon and historical status, as well as historical climate conditions and future climate conditions. If you have a high soil carbon today, if your soil carbon is 6 or 7 or 8%, then your ability to change a practice and improve soil carbon is pretty low. Whereas if you're starting from a low base, like 1% in a clay soil, for example, if it's degraded, well then your ability to change something and then improve soil carbon is fairly high. So it really depends on where you're starting from today and what deficits you have, whether that's environmental, whether it's in your production system, whether it's economic. So what is the biggest deficit and how do you address that constraint? To maintain soil carbon, you really want two different things. So you want to maintain growth. So what happens above ground generally translates to what happens to below ground. There's a bit of a lag effect, might be 1 or 2 years. So if you wanted to improve soil organic matter and soil organic carbon, improve your growth. So if you add nitrogen, provided there's going to be a response, you generally improve growth. And if you can improve seasonal ground cover, particularly when it's dry, maintaining some sort of ground cover, well then your soil carbon will probably go up. If you can't change your practice or your fertility to generally improve productivity, well then the probability that you can improve your soil carbon is quite low. To improve soil carbon, you can reduce cultivation, you can improve soil fertility, you can increase deeper rooted legumes, you can change your grazing regime, do cell grazing, many different things. If you implement a grazing regime to improve pasture growth, well then the probability that your soil carbon will go up is quite high. So soil carbon really depends on what's happening above ground and for the long term. We're lucky in that soil carbon moves in the same direction as soil organic matter and soil fertility. So if you improve your organic matter and your soil fertility, then your pasture production will increase, your soil carbon will increase, and so therefore your productivity will increase, your carrying capacity increases and your profit increases. We're lucky that it doesn't move in the other direction.